All right, what form are all these limits? Okay, do you want to see the answer? They're all 0 over 0. Do you agree with that? They're all 0 over 0. But each of them has a different answer. This is what it means to be indeterminate, right? 0 over 0 itself is not enough information to know the answer. The answer could be 0 or a third or infinity or 1. Could be any of these things. So the reason I say they're all 0 over 0 is because when I plug in 1 at the beginning, I get 0 on the top and 0 at the bottom for each of these limits. Every single one of these starts out like 0 over 0. Notice that 0 over 0 is never a good final answer for a problem, right? Like it's like you tried one thing and that didn't go so well. And now you have to do something else and do algebra. You don't just get to stop after trying the one thing. So in each case, we have to do some algebra. And when it's 0 over 0, your goal is usually to like clear the zeros, which means you're canceling something in the top and the bottom that is going to 0. So in each case, we actually cancel. If you have trouble seeing how we're canceling, imagine a parentheses around this x minus 1 right here. We're canceling one of these x minus 1s with this one. Or in this case, they're both x minus 1. Or in this case, if you put a parentheses here, these two pieces cancel. Or in this case, these two pieces cancel, but there's a square of 1 left on the bottom. So in each case, the first expression that I wrote in a color is the original expression with something canceled. And now that I've canceled something that, by the way, was going to 0, x minus 1 is going to 0. That's what's causing our problem. Once I've canceled in each one, I just plug in and see what happens. And in each case, there was actually a very easy limit, and you just get the answer. All right. Questions about that? The 0 over 0 is bad. The indeterminate is bad. But 0 over 0 is actually the least bad indeterminate. Like I think of things in order of niceness and badness, right? So like continuous functions are nice. Limits that I can solve by plugging in, those are limits of continuous functions. That's very nice when that happens. Sometimes something bad happens to you, like dividing by 0. But dividing by 0 always means what you have is infinite, so that's not that bad. 0 over 0 is a whole other level of bad, because now we don't even know whether the answer is infinite or not. And if it isn't infinite, we don't know what answer it is until we do some algebra. So 0 over 0 always means there has to be algebra, but the algebra is almost always ends up being some kind of canceling at some point, and then you plug in and everything's fine. These things, different terrible things can happen to you. These last three are tricky. And after today, when we talk about the forms, we probably won't talk about those again until MATH232, just because we're not doing the kinds of functions for which this situation would arise in 231. So we're getting straight whether they're indeterminate or determinate or non-indeterminate, but we're not worried about solving limits like that yet until 232. Thank goodness, because that's a whole other thing. Okay, so here's a flow chart. You can make a lot of different flow charts here. You can see, in fact, that at the bottom of my flow chart, not all indeterminate forms are down here. Like there's other things that could happen to you. This doesn't include everything. This is a good slide to take a picture or a screenshot of. It's in the slides, or you can take a picture of it. But really, you should make your own, and it should be on your one sheet, right? You should think about what is your flow chart solving procedure for limits, and then put that on your one sheet, okay? So here's how it works. You start with a limit. You plug in. That's always the first thing you do. You see what happens if you try to evaluate the limit. Sometimes that means plugging in a number. Sometimes that means x goes to infinity, and you have to deal with that. If you're getting number, then that is the answer, and you are done. Okay, so if you try to evaluate the limit and it comes out to be 5, guess what? Your answer is 5. Okay, that's done. If it is not a number, that's bad. And like I said, you want to know like how bad. If it's 1/0, it's infinite. You're going to have to look at whether the 0 is positive as it approaches 0, whether the denominator approaches 0 from the positive direction, or whether the denominator approaches 0 from the negative direction, because this first one will be infinity and the second one will be negative. Okay. And then the next bad thing that can happen is it could be indeterminate. We just talked about how 0/0 is usually a cancellation that you're trying to do. Infinity over infinity has a different trick that we'll see on the homework this week, which is that you divide by the highest power of n, of x. So like if there was like a quadratic on the top and a quadratic on the bottom, I would multiply by 1/x squared over 1/x squared. You'll see examples like that in the reading and in the homework. Very common for infinity over infinity to use that trick. Infinity minus infinity, that's like this one. This one started out, if you remember, like limit as x goes to infinity of root x minus x, and it went to infinity minus infinity. And so our strategy was to factor it. It works a lot at the time, and you have a infinity minus infinity limit. When there's 0 times infinity, that's an interesting one, because if you think about it, 0 times, oh, that's not what I meant to write at all. How can one thing come out of my mouth and the other thing come out of my hand? 0 times infinity is like 0 times 1/0, but it's also kind of like 1/infinity times infinity, right? Infinity and 0 are reciprocals. So if I think about this infinity as 1/0, then I can rewrite as a 0/0 type limit. If I think of this 0 as a 1/infinity, I can write it as an infinity times infinity, infinity over infinity limit. That's not going to make a whole lot of sense right now. It's very abstract what I said, but we'll see in some examples. That's going to be the strategy to turn that product into a fraction so that we can see it as 0/0 or infinity over infinity. All right, so that's my flow chart. Make your own flow chart. Questions about the pretty flow chart? Okay. So let's really drill down for this. I have a worksheet for you. It looks just like this crazy thing here. Your job is going to be to figure out where all these indeterminate forms go in this worksheet. So I'll give you a hint, like we just saw that 1/infinity, I think we saw, yeah, we did this on the quiz, 1/infinity always goes to 0. So you would write this one in this box. Okay, it's going to take a while to do this one. Try to find the low-hanging fruit first. What's obvious? Put the obvious ones in the right place first. And I will walk around. All right, Sarah, now's when I need you. While you're doing that, I want to remind you that Sarah is running these Monday sessions, and that those Monday sessions also include the ability for you to ask about what you got wrong on previous quizzes, which you need to do retakes. Monday night, 6 to 7, right? Is that right? Yep. 6 to 7, right over there. You feel stuck, try to find an obvious one. Then try to convince your table you're right about that obvious one. Check with your table sooner rather than later in case you get off track. are super bored and await your questions. You don't even know what the questions are, so we are for now. Well, which ones are you not sure about? So all those? I'll give you a hint. There's a lot of them that are. Oh, she's got a lot of her. I don't know if they're all right. You can find out. I would start there.
Infinity times infinity.
Infinity.
Infinity. Okay.
Yeah. Infinity times negative infinity. No, yeah. Just. I'm going to start putting them up here. I'm not quite ready to do that yet. All right, let's do some of the obvious ones. Which ones seem obvious to you? What's one that you're pretty sure about? Go ahead. It's pretty big. Yeah, infinity times infinity. And where's the other one? Infinity to the infinity are infinite. So check this out. This expression here, if the bottom approaches infinity and the top approaches infinity, both of those things are conspiring to make the quantity very, very large, right? There's no fight here. Same thing here. If you have a product of two things, each of which are growing without bound, the product also is growing without bound. Okay. The infinity ones are the easiest, I think. Yes. Oh, which one? 0 divided by 1? Oh, I didn't mean that. Sorry. I didn't mean that. I'm sorry. I don't know what I meant. I think I meant, these were in a different order than on my sheet. So yeah, where should 0 over 1 be? Dope. Yeah, sorry about that. Give me some more infinities. Infinity squared, a quantity that grows and grows and grows. You square it, still growing. Right, what else? Which one? 1 divided by 0 plus. Here, the denominator gets tinier and tinier, but it's positive the whole time it does that. So it's like 1 over 0.1, 1 over a tenth, 1 over 100th, 1 over a millionth. Because 1 over a millionth is a million, right? 1 over 1 millionth is big. So that one goes to infinity. There's some more obvious infinities in here. Infinity plus infinity, no fight there. 2 to the infinity, no fight there. Infinity plus 1, this is my favorite one because you know how like when you and your sister or whoever are fighting when you're kids and you're like, yes, and she says no, and you say yes, and she says no, and you say yes to the infinity, and she says no to the infinity plus 1. You are tied. in that situation. I really like that. That's the same as infinity. Infinity is not a number, so we can have that. Okay. Infinity plus 100, also infinity. Infinity minus 1,000,000. Infinity. Okay. You can add or subtract a number to the concept of growing without bound, and you still have a quantity that's growing without bound. Right? Okay. There's at least one more obvious infinity in here. Who can find it? Negative. Oh, that I think that one's a little bit harder, but yes, this. Well, this one, -2/0 plus. Let me compare it to 1/0 plus here. It's -2 times this one. So this one goes to infinity. This one goes to negative infinity because of the minus. So that one goes here. I was thinking of infinity over 1. There's no fight there. The 1 in the denominator fights to keep the fraction basically the same as what it is. And the infinity at the top fights to make the fraction bigger. Fine. The bigger is definitely just can happen. Okay, I'm going to give you a minute to think about ones that aren't infinity. So talk with your table about ones that are not. Oh, wait, there's one more. There's one more infinity. Can anyone find it? Oh, you know what it is? Look, there's 2 of these. Okay, I'll just delete one. Sorry about that. Okay, please work with your table with the other ones. I think some of them are tower ones. That looks like 1/6 almost kind of. So it's like that was okay, let's try a couple more. Does anyone have one they feel pretty confident about? Infinity times negative infinity is what? Negative infinity. I feel pretty confident about that too. There's no fight there. You have 2 things multiplied together. One is getting bigger and bigger. The other one's getting bigger and bigger while being negative. The product of that will get bigger and bigger while being negative. You're always looking for the fight. If there's a fight, the thing's going to be indeterminate. Does anyone see one that's indeterminate? What's that? This infinity over infinity? Sure. We saw that on the quiz, I think. The top is getting bigger. That makes the fraction try to get larger. The bottom is getting bigger. That makes the fraction try to get smaller. That's a fight. It's going to depend on which one goes to infinity faster. And you're going to have to do some algebra to figure out what that limit is. All right, what else you got? Infinity minus infinity is very good. Indeterminate, that's the one. I don't know why I erased it over there, but it was the one I erased over there. 0. Now that's a tricky one. What do y'all think? When you raise any number that's not 0 to the 0 power, what do you get? 1. So when this number isn't 0, even if it's very tiny, raising it to the 0 power tries to make it 1. Like if I had 0.00001 and I raise it to the 0 power, what would the answer be? 1, right? So, but on the other hand, if I have a very small number up here, or small number up here, and I have 0 to a small power, what's the answer? 0. There's a fight here. Okay. The bottom part is trying to fight to bring the whole thing to 0. The top thing is trying to fight to bring the whole thing to 1. It's not a very interesting fight because it's just between 0 and 1, but a lot of things can happen there. So this one's indeterminate. And again, we won't see any of these really after this week until 232. What else you got? 0/2. What do you think about that one? I put under 0 too. Yeah, there's no problem with that. And remember, I just want to point out, we're not asking what this fraction of integers is. We're asking if you have a quotient where the top is approaching 0 and the bottom is approaching 2, what does the whole thing approach? And then we're saying it approaches 0. Okay, that's a lot different than saying the number 0 divided by the number 2 is 0. That's not what we're saying. Although that's also true. We're saying that if you have something approaching 0 divided by something that's approaching 2, that whole quantity will approach 0. That's what we're saying. All right, what else? 0/0 is indeterminate. That's sort of the most famous indeterminate one. Excuse me for coffee. What else you got? What do y'all think about 1/infinity? What if it was 1/-infinity? I don't see that here, but what would that be? Also 0, right? Just approach it from the negative direction. Okay, here's what we got left. Just moving these out of the corner here. All right, what's left? 0/∞ is a which? 1. Well, let's find out. Hold on, let me look, because this is a weird one. I always have to think about the power 1. So in this case, if I have a very small number and I raise it to a large power, I want to know if there's a fight going on. Okay. So raising something to a large power usually makes it big, right? But what if the number you're raising to a power is very small? Remember, we saw that raising like half to a power actually makes it smaller, right? Raising a really tiny number to a high power actually just makes it even smaller. So what is this limit approaching? 0. This is a tricky one. This is a tricky one. And again, we won't see these too much until 232. All right, what else? Yes. -2/∞. It's just like this one, the 1/∞. Except these minuses cancel out if you like, and it'll end up being 2 times 0, which is 0. Okay, what else? Yeah. I agree, because you have some -∞ and you subtract more from it, right? So that's -∞. What else? I think this is probably the next easiest one here. What do you think this is? 1/0 minus -∞. Just like this 1/0 plus, see, on this side, that's infinity. This one's 1/0 minus. This is a super handy reference for you to have with you when you take a quiz. But you can't, you would have to write this on your one sheet. You can't use this as your one sheet, is what I'm saying. It has to be like a thing you constructed, but you could copy this on your one sheet if you want to, right? Or anything like it. All right, what else you got? How about this one? 0 times infinity. Is there a fight there? Yeah, that's a super big fight, because here, this number is getting small and this number is getting big, and we're multiplying them together. So it really depends how fast the small number gets small and how fast the big number gets big. That is a fight. That's indeterminate. How about this one? 0/∞. 0. It's like 0 times 1/∞. Let me write that so you can see what I'm talking about. 0/∞, you could think of as 1 over infinity times 0. And 1 over infinity goes to 0. So you really have 0 times 0 in this situation. Or if you like, you can think about it that making the top of a fraction 0 makes the whole fraction smaller. Making the bottom of the fraction go to infinity makes the whole fraction also smaller. So there's no fight here. Both the numerator and the denominator are conspiring to make that quotient very small. This is really important to be able to do this, because when you do a limit, think about what happens in the flow chart. The first thing you do is you plug in. And if you're letting like x go to infinity or something, you're going to get stuff like this. All right, last one's this one. Something makes the fraction big. The bottom also tries to make the fraction big, but it's from the negative side. So I would put that here in negative infinity, and infinity over 0 plus, I would put that here in infinity. Those are the hardest ones, I guess, or at least the last ones. I guess 1 was a red herring. There were no ones. If you get any of these forms for your limit, you're done. You know the answer. Okay. If you get any of the first 4 boxes. The last box is when you have to do algebra. Okay, let's call that a day. I'll see you on Friday.